Hello everyone, Geo Rollins here, coming to you from the GeoSphere. If you cross-country ski, I bet you're just like me and love skiing in beautiful, pristine cross-country ski track. But as you know, this isn't always possible. A warm-up in the winter weather, combined with rain or possibly freezing rain, can turn that track to ice. Well, what can we do about this? Stick around, and I'll show you the development of a tool that we built at our local club to help combat and restore that pristine track. A little background on this project. In St. Albert, Alberta, where the club is, sometimes during the winter we'd get a warm-up, a thaw, and we'd even get freezing rain or rain, and that would turn the track to slop. Then when the temperatures fell, the track would ice up and become basically unusable. Our traditional drags would just chatter across the top of the ice and we couldn't renovate the track. And so the idea came about of building a powered machine like the ones they use at the big ski hills, but not nearly as big and not nearly as costly. Something small enough that could be towed behind one of our snow machines. Something small enough, narrow enough to rip up and replace only the classic track. And so the Power Renovator was born. A machine that would rip up the icy track, pulverize the ice, and mix it with that dry snow underneath and set a new track all in one pass. This is a video of the process of building that machine, testing it, learning from those tests, and evolving the machine over the past few years. Now, I have to say, the machine works. It's not perfect, it has its flaws, but I have to say it works really well. And if I had to do it over again, I'd probably change some of the fundamental design elements to make it work even better. But I am happy with the way it turned out, and I hope you like the video. So this was the first stage mock-up of the prototype. Didn't like it. We went to a pan out of steel with the tiller head mounted on the front of the pan. The rotor was fabricated using a flow jet. We cut the teeth out of simply mild steel. Here it is with the bearings and powder coating. Next step was to mock it up with the motor. It was a Honda GX 390. It's a gearbox motor, 11 horsepower. And this one was an electric start. Used a 30-tooth sprocket on the front to get the gear reduction down to about 1,000 RPM from the 1,500 that the motor was driving. And the tiller mounted in the housing. Offset some of the teeth here to get better coverage. And a look at the front of the tiller. So the first test pulls just behind the truck. This cover is very nose heavy, had that suspicion, and didn't track very straight. Added some weight room weights, some kettlebell weights in the back. It's about 75 pounds there. A much better balance. But still tracking was a problem. But figured that would be solved when we added the forms for the ski track. So we added the forms of the shoes and on to the first test on snow. So that's about 100 pounds of lead weight on the very back. That's from one of our Ginsu groomers. And with the shoes it tracked very straight and actually left not a bad track. Not a bad track, but not perfect. Notice that with that big sprocket in front, that one ran in the snow. So left not a bad track, but still not the best smooth track that we were looking for. So without the weight on the back, it was very nose heavy. So after that first test, we moved on to the new tensioner assembly and went to a smaller drive or driven sprocket. Wanted to lift the tiller off of the snow, so we added an electric actuator to pull it off the snow, and notice the slot in the top there, that allowed the head to float on the snow by an inch or two. So this is just cycling through the up-down. Adding wings and combs on the front sides would also allow us to put maximum ground pressure, but prevent it from cutting too deep, as well as comb over the tracks left by the Sherpa. And they're adjustable as well through a slot, so we could set the comb. So here's a shot there of the combs doing their job, cleaning up the track of the Sherpa. In this test here, not quite set deep enough and don't have quite enough down pressure off the head, but pushing down on the head we noticed that it did leave a decent track, better than the first test. So one of our first problems was blowout out of the back. Now this was mostly due to a lack of down pressure on the head, as well as in this video we're going through quite hard ice. It's solid ice down a couple of 3-4 inches. And of course this thing's only cutting down about 2 inches. So slippery on the bottom, there was nothing for that milled up snow to stick to, and it just blew out once we got over the ice. Like you can see here, just a skating rink really. The second problem was side washout. So in this test the wings are off, but you can see quite a bit of that tilled up snow being blown out the side. Now this was just after a fresh little snowfall and in the midst of a squall, so we had nice snow, but in these conditions it actually left a very beautiful track. So in this test we added the wings to see if that side blowout would make any difference, and it did not. Still blowing out the side as expected, but at least it's combing. And unfortunately, with all that side washout, it just obliterated the nice comb work. As I said earlier, in these conditions with the snow, it left a beautiful track. And then blow out again from the rear on the ice. Still blow out despite putting a bit of a curtain on the side. Not a very nice track because of ice on the pan. We still have a blowout problem. So we combated this after test after test after test. We had a hard time dealing with that problem until one day on one of the tests I stood on the power head trying to just balance it out. We stood on the back where the weights were, trying to put more weight, but I stood on the head and it set a track. As soon as I got off, it started to blow out again. And I jump up back on the top, I stand up and give it a second here, and that blowout would stop. It would catch and leave a beautiful track. And as soon as I got off again, within a few seconds or a meter or two, bang, it would start to blow out again. So this was repeatable. So a combination of not enough weight on the head, right on the tiller itself, as well as a very slick or icy surface underneath that top layer, resulted in this terrible blowout. Now this was nearing the end of the season in 2017 and caused a lot of frustration going into the spring. But standing on top of it, we had a good success of leaving a nice track without any blowout. Now in this particular video, we're just ripping out an old track set by the Ginsu groomer and laying a new one with this Power Renovator, and left a beautiful track, albeit very, very icy underneath. We'd all but closed for the season due to the ice and due to the warm daytime conditions. But a decent enough track. So adding a down pressure mechanism. So this was the first test with it hooked up to the machine, a new tow bar assembly, and a small linear actuator on a leaf spring that telescoped. I needed a telescoping mechanism so we could still lift the power head. As you can see here, it expands again. And as we put the power head back down onto the snow, it arcs forward, and then we could put the down pressure using that small linear actuator. Now that linear actuator is capable of producing 270 pounds of downforce. And of course, the mechanism that's used there for the tow bar allows us to take the weight right off of the back of the Sherpa in order to use the weight of the machine to push down on the power head. So just trying it out on the snow, pressure on, and you see without having to stand on it, we seem to solve the problem of that rear blowout. Now this is going across a very icy bit of snow, very hard packed. It's a bit softer now that it's sort of midday, right around 0 degrees. In previous tests, without that down pressure mechanism, it would blow out something terrible. So that was a successful test. This came back from the powder coaters, sent it away. We were happy with the final design. A few tweaks to make on this iteration. Wheels, so we could move it on and off the snow and bring it into the barn. Got the battery mount, got a chain guard. Wings, everything looks pretty good. Still require 110 pounds weight on the back in addition to the engine. And then controls in the gray box there with the 2 switches to control the actuator for the power head as well as the down pressure mechanism. So here's no down pressure on the mechanism as we start the tow. A little bit of blowout there. As I move around to the other side, I apply the down pressure. And that linear actuator is extending. Turned it around this time just so it would be easier wired. And off it goes. Now the gray box has the switches for the 2 actuators. That's just so a person can control it beside the actuator. Of course, the yellow box there at the top of the screen is for the emergency cutoff. Now the whole unit is wired into the switches that are on your machine or on our Sherpas to control the pans. For the Ginsu groomers, we also use the same switches and the same wiring harness to control the power head, the up-down to take the power head off of the snow, as well as the down pressure actuator. And quite happy with this test. A few bits of wiring to clean up on it, but before I broke it down and brought it back to the ski club for which it was designed and built for, wanted to test it. And a lot of successful tests here. Now the speed in which it works is still quite slow. It's a walking pace. Can't rip up a lot of track very quickly with it, but it does a really good job. Now this is in very, very soft snow conditions with some icy bits underneath, but it tracked quite nicely, left a really strong and fast track, and set up in about 20 minutes, whereas when we would use our Ginsu groomer and just use the pans and drags, it would take about an hour to set up. So this sets up a really nice track quite quickly. And just a couple parting shots, kind of the general pics of the assembly with the actuator and the tow bar down pressure mechanism. If you enjoyed the video, please consider clicking like. And if you're interested in seeing any more of my projects that I build here on YouTube, please click the subscribe button below. Thanks for watching.